I've recently worked on a project where I had to create a cloth simulation for a fur cape, which also had to have some quite realistic groom. After looking around the documentation and threads for a while, I realized there wasn't any specific documentation on binding a groom asset to a simulated cloth asset, which is why I want to make this short tutorial. For this short demo, I'm going to be using Unreal Engine 5.1.1 and optionally Blender 3.5 in my case, with CentUE to create the groom and export it from. Now I won't be covering the Blender part in this video, but I'll link some resources for both using their new hair tools in Blender 3.5 and also getting CentUE up and running. For this setup to work, you have to enable Groom, the Alembic Groom importer, as well as, if you're using CentUE, the Python editor script plugin and the editor scripting utilities plugin. Next up in your project settings, you want to enable support compute skin cache, and if you're using CentUE, you additionally want to enable the Python remote execution option. Lastly, in your editor settings, you want to deactivate the option Use Less CPU in the background to speed up the import of larger assets in CentUE. After enabling all of these plugins and settings, you must restart your engine for the changes to take effect. So here we are in Unreal. By the way, it's totally fine to import your groom any which way, so the standard way with just an Alembic Groom cache also works. Same goes for your cloth mesh, you just have to make sure it's a skeletal mesh instead of a static mesh or anything else in Unreal. So first up, you want to open the Skeletal Mesh editor by double-clicking on your skeletal mesh. We're going to apply some clothing data to it by right-clicking it and then creating clothing data from section. Next up, we're going to apply this clothing data as well by just right-clicking it and applying. So next you want to head over to the clothing section on the left panel. If you don't have this open, you can go to Window and then open the clothing panel that way. We're going to activate Cloth Paint. And this is a really simple setup in this case. So I just select a brush tool and a paint value of 100. Increase the radius a little bit to 64 here. And then just paint the lower 2/3 of the plane that I imported. After I'm done, I'll switch the tool to smooth and then adjust the strength to B1 and hit smooth mesh a couple of times to avoid any hard or sharp transitions in my mesh. I'll then deactivate cloth paint and save the mesh. Depending on how many vertices you have, this will take longer or shorter. In general, I would recommend to keep vertices to a minimum for cloth simulated meshes in Unreal Engine, as otherwise the workflow might become super slow or just unstable altogether. Now we want to head over to our groom asset and double click that, head over to the physics tab and enable simulation here. Depending on your strand count, this can also take a while or it can be super fast. I opted for about 200k strands for this example here, and this is also what I used in the project where I had to create the fur cape. So the compute for the simulation is almost done here. And next after this, we're going to head to the materials tab. And if you haven't already done so, create a material slot for your groom in here and set up a little material. What I mostly like to do is import a basic metahuman into my project and grab the hair material from there, or just migrate the asset over from another project. After this is done, we can hit save on the asset and close it to get back to the content browser. In the content browser here, we'll right click on our groom asset and hit create binding. We will bind the mesh to our plain FBX that we imported earlier and just hit create. You then get a little preview window of your binding asset. This is all fine. You don't have to change anything here, save it and close it again. And we're done setting up the groom asset. It's now time to bring these two together, which we can do by heading over to the skeletal mesh and creating a blueprint from it. We right click it and then head to asset actions and create blueprint using this. We can give it a name and set a location for it. And after this, it will just throw us right into the editor for the blueprint, which we will just quickly compile and save before heading over to the skeletal mesh and adding a component. We will add a groom component and just name it fur. And after this, we will head over to the details panel and link our groom asset in here and also link our binding asset in here, which we created earlier after editing our groom asset. Now, this will be sufficient if this was a standard skeletal mesh, but for a cloth simulation, we need to do one more thing, which is heading over to skeletal mesh and searching for skin. When you search for skin, you find skin cache usage, and you need to create a new array element here. We then select enabled for this array element. And this is it. We can now compile and save our blueprint, and then head back to the content browser. From here, we'll just head over to the blueprints folder, which got created when we created our blueprint, and then grab the blueprint and drag it into this level, zero out the location and rotate it towards the camera. So next up, we're going to the place actors panel and we're searching for wind, and we grab the wind directional source to just preview our cloth animation. We set the strength and the speed both to 5, and keep in mind that the gust amount and the radius don't currently work with the Chaos Cloth solver, which Unreal is using since Unreal Engine 5. When we now press simulate or hit Alt-S on our keyboard, we can see that our setup works. It's really great that Unreal supports these kind of complex simulation interactions, although you have to keep in mind that the usual limitations of these simulations and of Groom physics especially apply. To name just one of them, at the moment you can't use temporal samples when rendering in a movie render queue and overwriting the anti-aliasing method. This actually goes for all simulated components, so it's best to stick with spatial samples if your scene contains cloth, Groom assets, and the likes. Also, you have to keep stability and performance in mind. In my use case, which was a cinematic, it's fine to use very high resolution settings for grooms and vertex counts that might not be rock solid. However, if you're working on a large production or if you're shipping a game, I wouldn't recommend using large grooms or high detail cloths or stringing them together like this, especially if collisions are involved too. For this particular setup, I haven't tested collisions all too much, but the same parameters that apply for cloth usually should apply here too. Lastly, if you have any questions or recommendations on how to make the setup even better, feel free to put them in the comment section. Thanks all for watching.